Hi, everyone. My name is Travis Rector, and I'm a professor of physics and astronomy at the University of Alaska, Anchorage. And I'm also a member and organizer for a group called Astronomers for Planet Earth. And today we have Dr. Faustine Cantalloube from the Max Planck Institute for Astronomy. And we're here to do the Q&A session based upon the talk that she recorded for us a few weeks ago. So thank you, Faustine, for joining us today. And so this is just a Q&A session to talk about some of the things, to follow up some of the things that were in your talk. And so the first one I wanted to start with is in your talk, you discuss about how it is becoming too warm at the observatory sites, that the telescopes are designed to be climate controlled to keep the telescope within a certain temperature range, and it's now getting above that. So my first question for you is, what are the, how difficult is this problem to solve? What will the observatories need to do to be able to maintain the temperature of the telescope so that they'll function optimally?
Yeah, so it's a very good question because it depends on the size, of course, of the dome, of the enclosure of the telescope. So the amount of air you have to cool down. As for the VLT, very large telescope I'm talking about in the talk, so we don't really know why. Actually, we have this cutoff at 16 degrees. So we're discussing with engineers, and actually no one really knew about it. But we think that there might be some ways to just like increase this cutoff temperature of 16 degrees. And some work has been done on the neighbor telescope Gemini South, so in Chile at Cerro Pachón. And in this one, actually, for saving, I guess, money and some other operation cost, they suppress the cooling of the system. And so some collaborators, Thalys et al., I think 2019, they studied the effect on the quality of the observations. And so they really see that there's some important, so if I remember well, the paper says that the most important cooling is actually the primary mirror. So that could be also a hint to say, okay, if we need to cool something, then these elements needs to be cooled down and so on, or just instruments. And the other thought is about ELT. So we thought about it and we're like, okay, now we're building the ELT. It's going to be huge enclosure. And again, if I'm correct, what I heard is that they plan to cool down the whole dome inside. So it's a huge amount of energy. And so, of course, you want to make sure that it's useful, that we don't have this gradient between the outside and the inner air. So yeah, my point was to try to discuss with the people and to push forward with this analysis of the trend of the temperature the next 50 years, even 100 years maybe, and to see what is the most optimal setup for that. And also the last thing that we're trying to do now is to look at the instruments themselves, so directly, so not only the telescope with the enclosure, but also each instrument. So most of them, they're within cryostats. And so we might actually find some information about this in the cryostat metadata, the telemetry. And same thing, like for instance, one of the first light instruments of the extremely large telescope is called METIS. So I'm working on that with Leo, who is also like a very active member of Astronomers for Planet Earth. And so same thing, we want to make sure that what we see today with the very large telescope, we can extrapolate it to the extremely large telescope, knowing that we're going to have this ramp up of temperature.
Interesting. I hadn't, even thought about the size of the ELT enclosure and just the sheer amount of energy that it'll take to regulate the temperature inside. So that's quite remarkable. I know from experience, at a lot of these observatories, just getting enough power to operate the facilities is a challenge. So has there been any calculations into how much additional energy it'll take to maintain the temperature?
Yeah, actually they did an energy budget recently. So I'm talking, when I say they, it's the European Southern Observatory. So it's not public yet because they want to make sure that they have solutions, which makes a lot of sense before spreading the news. But I'd be happy to give you contacts for discussing this topic. So indeed, the cooling system is one of the major source of energy consumption on a daily basis because it's very regular, but there are many other operation costs, obviously, the hardware, the software, and everything. So they're discussing about it, and I know that the DG, so there is an ESO news thing about they really want to have as much energy coming from solar power plants. So let's see how it goes. And La Silla Observatory, which also belongs to ESO, has like a huge solar power plant that is feeding most of the telescopes, but not all of them. As for the other observatories, I don't know.
So I've seen the solar array near La Silla. Is that array specifically for La Silla, or does it just happen to be right next to it? Do you know?
I frankly don't know, and I don't want to say anything. I don't know.
That's a question that people often ask is, I mean, obviously we build these telescopes in places that are clear skies, and so that would mean, at least during the daytime, a lot of sun. So what is the, at Paranal, what is the land situation like? Is it realistic to install a solar photovoltaic array that could provide most of the power for the site?
Yeah, I think so. So recently, so they used to use diesel for cooling, for instance, the cooling of the systems, and now they changed their on the grid, close, like linking with Antofagasta, the nearest city from Paranal Observatory. And yeah, I think, yeah, I think technically it's completely possible. I don't know exactly what's the state. I can't really speak up for ESO people working those aspects. But again, I'm happy to give you contacts to discuss that because I'm really no expert in those things. I'm not even part of ESO.
Yeah, that's totally fine. So one of the other, one of the other concerns that we astronomers have is for the long-term viability of our astronomical sites. If we are building telescopes in a place, we want that site to remain viable for many decades. And I know that, the Atacama Desert is being changed by climate. You're hearing stories about it raining in places that it's never rained before, flooding. Do you have a sense of what the long-term impacts will be? Whether it be the percentage of cloudy nights, or, I mean, obviously in your talk, you talked about the stability of the atmosphere. Is there modeling available that indicates how our sites look to be affected?
So it's a very good question. And actually for the humidity at Paranal Observatory, it's kind of for now, it's kind of a gamble. We don't really know. We know it's going to change because the global circulation will change in the southern hemisphere, but we really don't know to what extent because everything is linked together. So for instance, as I said, I think in the talk, like what happens in the Amazonian forest can affect like the way like the humidity is transported onto the Altiplano, which is this very dry area after the Andes. Eastward of the Andes. I'm always like mixing up east and west, something like that. But for your question, so actually one way of also like thinking about it is like, how do we choose a new telescope site? So the way we usually do, so there is a trade-off between, of course, we want to have like a very clear sky with no light pollution for the visible infrared telescopes, but also accessibility. So we want a telescope that is not too far away so we can install the instruments, make sure that we commission everything that can bring visitors there. And this is an important aspect, and that's one of the reasons why as well, for instance, the Royal Amazonas has been chosen for the ERT site, so that is quite connected to the VLT site, even though I think the future telescope will be more and more automated. And even current telescopes, they were Gemini or VLT, they were encouraging more and more service mode observations. Let's see how it affects the quality of the science which is done with those telescopes. I have no idea, but that's a question. So that's one thing. Actually, for Chile, I wouldn't be that worried because in any case, it's one of the driest place on Earth. And all those things I talked about in my talk, I mean, they're, I think, interesting because we can monitor that for like more than 30 years and discuss on those basis, but it's still very, very good quality sites. And on top of that, we're on the, we're having new technologies, new devices that can catch up with those worse conditions, other conditions. So I think we can bring like new detectors, for instance, more sensitive new things that can only catch up, and we won't see the effect of climate change in the quality of our images. That's one point. However, the other point, which is very important, and I didn't have time to talk about it during the webinar, is all the places. And we all know that the huge forest fires that happened in the USA and in Australia destroyed some observatories, half of them, all of them. So I'm thinking about Siding Spring Observatory, which was half burnt a few years back, and also the other one, I can't remember the name, but there are a few of them. And more we see pictures of the LBT surrounded by fires. The Mount Wilson was that close to get burnt a few months ago. And this is really worrying. And we know that those huge forest fires are more and more prominent, more frequent and stronger, bigger because of the climate change. So that's one thing. And the second thing that really worries me is the hurricanes. So we really today hear a lot about those hurricanes happening. We have more because climate change, actually there was Nature paper yesterday, because the ground is getting warmer. It means that the hurricanes can actually go further out in the land. So when you have the ocean and then you have the land, then the hurricanes usually kind of stopped at this limit. But now it can go way further out, and they were like stronger and so on and so on. So you know the story. So hurricanes are going way worse with the last few years. And even the scaling system that we used before was between, I don't know, 1 to 5, and saying nothing. And now we go to 8, 10. Like the strength of the hurricane is like definitely increasing. This said, we don't have telescopes on islands such as Hawaii. And if Hawaii is on the path of one of those hurricanes, then it might just, destroy completely this amazing site. And it's not this, I'm talking only about like big observing sites, but there are also like many small observing sites that they're less famous, but they're still there. And I think it's really sad to lose those sites. So I would be worried mainly about those two things.
Mm-hmm. Yeah, I mean, that's certainly this fall in the United States, Lick Observatory and Mount Wilson Observatory were both came very close to being destroyed by fire. And of course, we put telescopes on top of mountains that are often heavily wooded, and we also have limited access, and so it can be very difficult to get firefighting crews to locations to protect these observatories. And so that's certainly on the minds of many American astronomers as we've watched those two observatories come very close to being destroyed. So. So the other thing the other main part of your talk was about how this is impacting high resolution imaging. Are there things that, technologies or other things that on the horizon that may be able to help with the increased image stability? I mean, is, multi-conjugate AO, are these, what does the future look like for high resolution?
Yeah, it's a very good question. So actually it's easier. That's really like when I know more, it's more like my topic of research. So actually the main things, what would make a massive step, I think, in terms of instrumentation are detectors. So for instance, you probably heard about those magnetic kinetic inductance detectors, also called MKIDs. And those, for instance, are photon counting detectors. So if we have this thing, then it means that we can go really fast. If we can correct really fast for the atmospheric turbulence, then we can get rid of the main errors, which are the temporal error, the fact that the turbulence is moving faster than what we can correct with our telescope. And we can do like major science and get way more sensitive. And same for the resolution. We could, use speckle imaging things which are using short-term exposures, so very short-term exposures, and trying to find information within those short terms, with those short exposures. One other thing, so this was for the detector part, it's my opinion again, I'm not just saying that. I really think that the main step, the next step in instrumentation is going to be detector. The other thing is actually all of those, probably you heard about those predictive control and predictive observing conditions. So the idea is to use either artificial intelligence methods to predict what is the turbulence coming in with the data that we have, and so that we get rid of this temporal error I was talking about. So you kind of correct what you're gonna have before having this delay. So that's one main thing that would really, I think, clear a path in terms of high angular resolution. The other thing, it's quite similar actually. I don't remember what I want to say. But yeah, so using all of those like new techniques, new control techniques and everything. And the other thing, the same way, is like now we're trying to predict the observing conditions. So this would enable a better scheduling of the observations, but also like, make sure that we adapt the system to the observations we have. So for that same, they're using either artificial intelligence techniques or more probes as well, more turbulence profiling, or even triangulation between different observatories. So that's another field, which is atmospheric science for astronomers, or astroclimatology. It's actually called like that. Which is really like getting towards a new step with the new 30-meter class telescope ongoing. Yeah, I think that's it. I mean, there are many other things, but that's the main thing I would think about, like in terms of prediction of the observing conditions, predictive control for the instruments, and better detectors.
Interesting. So as it is now, Adrian brings up the question of the variations in the atmosphere and how rapidly they occur. How often are there nights that the conditions are too turbulent or too variable for the AO systems to operate? Are most nights usable, or is this, and in particular for climate changes, what is the trend on these nights, as far as decreasing?
Yeah. No, it's a very important question. It depends on the science case. So one of the things I'm working on, I think actually in the webinar, is called the wind-driven halo. So this is exactly this flare that we see in the images due to the jet stream layer that Adrian is talking about. This without the high contrast imaging part, so without any coronagraph, so without any techniques doing exoplanet imaging, let's say, we don't see it at all. So it's very faint. But as soon as you use a coronagraph, you go to such a high contrast regime where you see really tiny aberrations, turbulence effects. You really see those. And we discovered things that we really didn't think about. That, for instance, we saw some asymmetry, which was due to interaction with amplitude effects. So this twinkling of the star effect, which we really didn't think about because it was so faint that was like, oh yeah, it's not going to play a role. But it actually does. So when you're doing such a sensitive imaging technique, which, as you know, as astronomers, is very trendy those days, so obviously we have to work on it, then the jet stream, for instance, plays a major role. As for the occurrence rates, I've been characterizing this wind-driven halo, and we found out it's a preliminary thing because we want to make sure that we have more than 4 years of data. Why 4 years? Because I told you during the talk that the jet stream is evolving with El Niño Southern Oscillation, which has a period between 2 and 7 years. Average period is 4 years. So if you have 4 years, you can cover one Niño event, which is the warm phase of El Niño Southern Oscillation, and La Niña event, which is the cold phase of El Niño Southern Oscillation. So now we're processing actually the 4 years of severe data. So this high contrast imaging instrument at the Very Large Telescope. And so the occurrence is about like 40%. 30 to 40%. That's quite a lot, actually. It's a huge amount of data.
Well, that's a lot. And this year is a La Nina year, I believe. Is that? I mean, that's what we're experiencing here in Alaska. It's remarkable how La Nina. The ENSO variation just affects, from Alaska all the way down to Chile. So, how much, just the extent of the impact.
Yeah.
Switching gears a little bit, I know that ESO, along with other astronomical organizations, has done an inventory of its carbon footprint. Have you been involved in that process? So
for MPA, which I'm working in today, I was working on this climate quality, the impact of climate change on the quality of the astronomical data. So I didn't take part of that, but I'm part of what we call the sustainability group. And I think I encourage every institute to form a little group of discussions, and we do stuff like, for instance, this how to best to optimize your use of your computer, for instance, to make sure that you don't waste energy. Same for the heating system. and some stuff like that. So for the researchers of people working at MPA, and also some more advanced analysis of our carbon footprints. We might actually hire someone like ESO did, the European Southern Observatory, they hired the company to do the carbon footprints of the World Institute, because that was too many things they needed. So that's what we were doing. And I know that, so I'm going to move to, as I think you said in the introduction, I'm going to move to Marseille, France in February, next February. And I know that they also have like a sustainability group thinking about the similar actions ongoing. And the CNRS, the organization of research in France, put a lot of things on the table saying like we should go toward a greener way of doing research. And there are tons of as well of organizations like I have too many in mind, like Scientists for Future, of course, Astronomy for Planet Earth, but Labo 1.5 as well, which is they're all like very interesting ways of acting as researchers against these changes.
So, I mean, certainly we can, as a professional society, we need to determine our carbon footprint as the first step to determining what steps we can do to, reduce our carbon footprint. I mean, the thing I found most surprising, maybe this because I'm an observational astronomer and don't think about theoretical work, but I was surprised to learn that computing is as much of a carbon footprint as travel.
Yeah.
So that was interesting, disturbing, I guess I should say, to learn the extent of that.
Yeah, it really depends on the institute. I had exactly the same. I was really surprised by the results of this survey in Australia, at MPA and other institutes, that depending on the institute and depending on what they're doing. For instance, at MPA, it was the air travels, like intercontinental flights mainly, to go observing. So to go to Arizona for the Large Binocular Telescope, to go to Chile as well. That was really the main stuff, but also to go to conferences, because here at MPA, we're really encouraged to go ourselves to conferences. Back in France where I worked, it was like no more than one conference a year, and maybe even one international conference every 2-3 years. So it was really not the same mindset. So I travel way more at the Max Planck Institute than back in France. And in Australia, it was the simulations, and at ESO, I think I can say, it's mainly the purchase actually. So they have huge optical labs, and they're of course buying tons of components to do the thing. And this was actually the most important thing, more than buildings, more than air travel, at least for, if I understood well, for the headquarters. Which is quite interesting, because to me, I thought it would be air travels for sure. I mean, they were commuting from Germany to Chile every so often, which makes sense. I mean, it's their job. But,
Yeah, I would imagine though for ESO, particularly with ELT underway, that there's, things have shifted, that there must be, quite a carbon footprint with the construction phase for ELT. So I mean, each institution will have, a different carbon footprint in some ways, but it seems clear now that the two main carbon footprints are air travel and computing power. And so, it's going to be up to us to determine how to reduce those. Now, obviously, with conferences and with COVID, we're all learning now how to do things online. And I mean, I don't know the extent. Does ESO have? I mean, does it have Q observing, or you mentioned service observing earlier? Is ESO still primarily in-person observing, or?
So not anymore. So I don't have the numbers in mind. I knew them at some point, but so I don't want to say bad numbers, like the wrong numbers. I mean, incorrect. But yeah, they actually reserve a fraction of time for visitors and another one for service mode. And it's actually, we know when writing ESO proposal that it's actually sometimes easier to get time under good conditions, with observing conditions, if you do service mode, because you don't have to care about it. They were just like Q observing mode. But they also noticed that if people don't go on site, then they care less about their data somehow. You have kind of a, I think Adam is reacting like, I guess you agree with that, like when you go to the telescope and you see the observation, going on your, like, it's your data and you really care for them and you really want to extract the most out of it, like, quickly on the fly. And when you receive your data, I don't know, be here in Germany, I receive my data via, oh yeah, I'll do it later. And then it takes months, and then I just, it's not the same involvement.
That's an interesting question. I have no insights, and I don't know if anyone's done an analysis of are you more likely to publish data that was obtained through Q or service observing than if you're there in person.
I think ESO might do that, actually. Maybe they have done it already. So
yeah, that would be interesting to know. As you probably know, Gemini is primarily Q observing now. There's less and less classical observing going on, and it's still, obviously a highly productive scientific instrument. So yeah, that's an interesting question as we transition to a future of, especially with things like, Vera Rubin Observatory, with the LSST survey, that more and more data will be obtained online, and how people's relationship with that data will change. Speaking as someone who loves to be at the telescope, I'm reluctant to give up that experience, but at the same time, living here in Alaska, every trip is a big trip, and getting from here all the way down to Chile for observing is at least a 2-day trip almost each way. And so that's a lot of time that's lost to travel. And so I can speak to the benefits of remote or Q observing.
Yeah, I think also this depends on your stage of career. Like we discussed a lot about this for conferences as well. Because when you're like a student or early career researcher, let's say, you're more inclined to go to a telescope. It's probably less tiring, so you probably have less. It's more discovery. It's very interesting as well. I mean, you learn so much by just going on the telescope. So I would be keen on like encouraging students to go like a few times. And also, as we say, like if you've been once, it's exciting. Twice, it's amazing. Third time, and then fourth time, you know what it's like. Like at the beginning, you have like sparkles in your eyes, and then at the end, you're like really tired of your journey, and you just want to go home, right? I mean, just exaggerating, of course, but there is a bit of that feeling like at some point you're like, okay, I've done it. And I would be happy actually to give the chance to anyone to have these sparkles again. And yeah. I'd be happy to, once in a while, of course, I would love to go to telescope. Because one other thing, which is quite important to keep in mind is doing astronomy is very hard, you know that, right? Doing research in astronomy, making your own path in it, having career is very difficult. So traveling and mostly going to telescope is usually huge motivation for most people. Like I remember like some very dawn times when I was at the telescope, I was like, okay, that's why I did all these things. And that's such an important aspect as well about work. So I think we should know, we really have to think how to optimize this, taking into account our own perception of the work we are doing. Same as for conferences. I mean, one of the big things, like to go to conferences and meet with collaborators, future collaborators, people from all over the planet. It's something very exciting about our job, also very exhausting, I have to say. And one of the papers from the Australian community, astronomical community, said that basically the senior researchers were traveling more, which when we saw that, it's like, okay, there is something clearly wrong because they don't need to self-advertise. They do have a job. They have like everything, kind of. Yeah. So let's encourage the students and PhDs and early career researchers who actually, we know that they also do most of the work. The cutting edge science is done by early career researcher. That's unfortunately a fact. And I'm just like in between the two lines, so I can still speak. But yes. I'm not completely not early career researcher yet. So, but you know how it works, and I think that's also something worth discussing and thinking about how to make sure that the community is rolling.
And you bring up a really important point, and that is the ability to participate in astronomy, who gets to do it and who has access to travel budgets to go to conferences and to go on observing runs. And as you mentioned, the Australian survey, where they found that senior researchers had like 8 to 10 times the travel budget. And I'm not picking on Australia. I think that's true everywhere. And so I think whether it be climate change or COVID, it's time to have an important discussion about the fairness of our profession and what are the things that we can do to ensure that everyone has an opportunity to participate and be successful. And so, you know, every time I'm at an observatory, I get that the sparkle in the eyes you're talking about. I mean, I'm always happy to be there, and so I'm definitely reluctant to give that up. But I also recognize that it's important to give people that experience who've never had it before. And so I think as we move forward into more and more, you know, Q and remote observing, that we still maintain an experience for early career astronomers to go to a telescope, use one. And actually, I think a lot of these small aperture telescopes that, you know, are being closed down or risk of closing, that's where those telescopes have tremendous value, because it is, one is it's such a hands-on experience, you know, using, you know, finding a guide star, focusing the telescope, doing all these things that are now automated at the larger observatories. That's where you really learn how a telescope works. And so I think we need to maintain that experience for students, but I'll be very reluctant to give up the
so yeah, one side note for the giving up, sorry, because maybe I didn't say, I was more thinking about colleagues of mine who went like 6 or 7 times a year, and they were like drained by the journey. It's like,
oh, sure.
With like, you know, like this kind of excess thing. And I thought in that case, it would be more, you know, better for them and also for the community and for, of course, the carbon footprint. Just like say, okay, I'm going there for like 2 years. I'm staying there, and like, you know, I'm having collaborations. I'm commissioning my instruments or whatever. I think that would be the way to go, which doesn't seem to be the case for now. But and as like, so on the same tone, I think it would be good as well. So for instance, when we ask for funding for specific projects, and if we say, okay, this person's gonna travel this in that place, that they can stay a few more days and like give seminars, talks at different institutes there, and start collaborating, staying there a little bit, because I've seen too many people going to conferences for 1 week and then leaving. And I'm like, what you do? At least take some holidays, you know, and enjoy the country where you are. Which actually, for the case of the Max Planck Society, is forbidden to take more than 1 week of holidays after. So it's also like shortens the holiday time. But I think it's really worth having this new mindset, or like we are sharing more. Like for instance, last year we had a conference in Japan, and I was thinking it's such a shame. Like we were coming to Japan, and most of the people, I mean, there were many, of course, westernized countries represented, like Australia, but also mainly USA, a bit of Canada and Europe. It was a huge crowd. And I was like, but that's the moment where we could actually, you know, really do something where we don't stay, have like little hubs and like discussion things to avoid this separation that we already have today. Yeah, specifically with Asian country, actually, North Asian country.
Well, the Australian model of when you leave your country, you're gone for, you know, a month or so, just because it takes so long to come and go, is probably a good one. I mean, that's how I feel in Alaska, that, you know, even just traveling within the United States, because, you know, traveling from Anchorage to New York City is a longer trip than going from New York to Paris. So, you know, every trip for me is a long one. But I think, you know, especially for early career astronomers, that face-to-face experience is still really important. But I'm, you know, with COVID, I'm finding that I'm able to participate in many more conferences and workshops, and particularly there are conferences that I may not have had the travel budget for, or it wasn't worth my time to leave for a week, but, you know, I definitely would enjoy participating at some level. And so I think all of us are seeing an increase in our participation level in these online conferences. And so the challenge will be to define that balance between, you know, the value of the different experiences. And you know, for me, it's been great in a lot of ways. I mean, for example, you and I have met online, and, you know, there's many other people that I've gotten to know that I wouldn't normally have had the chance to do so. And so I think that the value of this virtual experience is proving itself. So the profession of astronomy is always changing, and you know, there's, you know, I've been around long enough to remember when people were saying, you know, oh well, you know, photograph, I wouldn't trust anyone to take my photographic plates for me. That's something I have to do myself. And now we're talking about fully automated surveys like LSST. And so, so the profession continues to evolve and gets better and better. But it's interesting, as we do this transition, especially addressing climate change, I hope as a profession we can also use this as an opportunity to address existing inequalities.
Yeah, clearly. And I think it's very important to do that transition, keeping in mind also like the situation of research generally, like the Alicaro researcher issue and all those things, to make sure that we increase diversity and all of those aspects all together. And to me, actually, climate, those reducing the optimizing, let's say, the carbon footprint of our occupation or research in astronomy is a good argument to make those changes, to make sure that we include as many researchers as possible and protect, in a way, Alicaro researcher population. So. Yeah.
Well, Faustine, thank you so much for taking the time to meet today and to go through the Q&A. And let's see, I think Adrienne maybe had one more question here. Said I was interested in her point about observatories having good weather stations in the Southern Hemisphere. So, Adrienne, do you want to jump online? You're muted there.
Hi there. I just want to partly say thank you. That was a really interesting webinar that you gave, and I already mentioned that I was interested in that AO having trouble keeping up with things when that was alarming. But the other thing that was interesting to me was your point about weather stations and fewer of them, less landmass and fewer weather stations in the Southern Hemisphere, and then observatories, of course, like the Southern Hemisphere, the Milky Way being where it is, the center being where it is, and among other things, and that we have a bunch of really good weather stations at various places around the world as a result. So that was interesting to me, and your ability to track things from these weather stations. Do you see that as something that more sort of interplay between astronomers and climate scientists?
I think so. I wish it will. I think it's already the case for big observatories that they work with. So for instance, again, Parallel Observatory is close to Antofagasta, the nearest city, and they launch, I think twice a day, a balloon to have like the profile of the atmosphere. And I think there are already interactions, but I would love to strengthen those things, because when I interacted with climatologists, they all say, or atmosphere scientists, they all said the same. It's like that everything is based on data, and we have really less data in the Southern Hemisphere. And I'm sure we could, at Astronomers, maybe have more interactions. And so we do have know-how. Like for instance, you have those people. I'm thinking about Elena Machiavelli doing those mesoscale models, and she's already collaborating with some climatologists. And it would be very interesting to really link. I think that's one of the main points. The global scale, so the large synoptic scales, with turbulence, which are something very small and statistical. Right. So I don't know if it was the point of a question, but
no, I was just curious, and it just struck me as an really interesting point, and there's possibilities for collaboration and sharing information there. Yeah.
And again, like my wish is would be to involve more scientists from local scientists, like people working in Chile. So I know that one of my collaborators, Suzanne Crevel, she's already working with a few Chilean organizations. Some engineers at ISO, like Florian Kerber, he's working on humidity, and so involving Chilean scientists, which I think is very important to make sure that we share that knowledge and those data.
Yeah. Nice. Great.
Well, Faustine, thank you so much for taking the time to meet with us today, and I look forward to talking with you again.
If you're interested in Astronomers for Planet Earth, you can learn more at our website, astronomersforplanet.earth, and on social media as well. If you would like to be notified about future talks and events, please follow and join us.